Hi, it's Dave. I'm joined by James Douma. This is based off of Andrej Karpathy's latest Tesla full self-driving progress update, which I'll link to in the video description. So we went through kind of a myriad of different topics, giving context into data and what Tesla's doing. And in this episode, I want to focus on auto labeling. I think this is part of the secret sauce that Tesla has with their full self-driving. Wanted to unpack it for folks and see if there's anything new or any updates, any color we can get on how Tesla is auto labeling their data and what impact it has on full self-driving. So welcome back, James.
Hey.
All right. So I want to dive into this area of auto labeling and try to ask you to help us kind of, unpack and make it clearer. So my understanding is they've had to basically, do a few things over the years. One is they had to fuse all of the cameras together to get kind of this one view. And then I guess we can call it a bird's eye view of the situation. And then they have to identify all the objects in that view. But then what Tesla's doing recently is they're now identifying not with radar, but they've removed radar. Now with purely vision, they're identifying the depth, the measurement of basically all these objects and if they're moving and how fast they're moving. And they've created kind of like this 3D bird's eye picture of all of their surroundings and all of the movements of the objects in that view.
Mm-hmm.
And that,
I have that slide.
Yeah, and by doing that, that's, and this is just a recent thing, that they've removed radar to really double down on vision. By doing that, that's significantly, or at least potentially has significantly increased the consistency, maybe the reliability and the performance of full self-driving. So I'm wondering if you could help us kind of unpack this auto labeling, if Karpathy kind of shared any more details or insights, what Tesla is doing, and any other thoughts.
The word auto labeling. So auto labeling is a particular benefit that they are getting from this process that Karpathy has highlighted a couple of times when he talks to technical audiences, because technical audiences know that actually one of the biggest problems with gathering certain kinds of large data sets is labeling it, right? And Karpathy in earlier talks he occasionally talked about how labor intensive it was to have people sit down and, draw perfect boxes around all the cars and label all the grain zone. And, that all of that stuff is, if you have a human being do it, it's incredibly labor intensive. And your ability to grow your data set is then limited by how many trained, diligent, professional labelers that you have. Because it's a hard job. They're labeling thousands of different objects. They put them in all these different categories. Sometimes the rules are kind of vague. They have to be, they have to think very carefully, about what those rules are going to be, about when something goes in a box, and you draw about exactly how big the box should be, and all that kind of stuff has to be figured out. And then the labelers have to be very, very consistent. Otherwise, your data set's not clean, right? Your labels have to be good. So naturally, this is a target that you want to throw automation at. To the greatest extent possible, you would like the labelers to have really good tools that help them label the stuff that they're going to do in the boxes. And you can come up with really great tools that can greatly leverage what your labelers can do. And the holy grail at the end of this, of course, is to have all the labeling just be completely automatic. That would be true auto labeling. But the question is how do you get really good labels, right? There's different kinds of approaches that you could take. And an approach that Tesla can do and that they decided to do is to do this training from video. And training from video is another component of this. Actually training the neural networks using video segments, that's another component. But as long as they're gathering the video components from all 8 cameras that have these overlapping fields of view, and where it's a car in a city scene traveling through an environment, there are certain things that you can dump that information into a computer with all of those chunks of video, and the computer can do this thing where it figures out what the scene must look like. Like it builds a 3D model of the scene where fire hydrants appear in the overlap. A fire hydrant of this shape and color and whatnot has to be at this location in the 3D scene so that it appears in this place in this camera's field of view and this place in this camera's field of view, and we know how fast the car is moving. So we know how fast all those objects should move, like how they should change as they move through the field of view. Well, you can take all this stuff that you know about the 3D, what the 3D geometry of the scene must be, and you can take the whole video clip, right? Because you got 10 seconds of video. So that fire hydrant, it might, if you drove past a fire hydrant, you saw it on, 2 cameras in the front and then one on the side and another on the side, and eventually you saw it in back. And you've got a whole bunch of clips from each one of those things. So if a computer looks at all of those frames of that fire hydrant, it knows that fire hydrant pretty well. Like it can predict exactly where it is and exactly what color it is and it can do that for every single object which is in the vicinity of the car when you get one of these 10-second clips going through, right? Okay, so now in the computer's memory, you build this 3D scene in great detail. It's got all the pedestrians. It has the birds flying by. It could have all kinds of things, right? Every object, everything of interest that was in that 3D volume that the car went through, you can figure that stuff out because you've got all of this information. You've seen all these objects from multiple angles, from multiple cameras. Okay, once you've built this really detailed 3D scene, which you can do, and you can do incredibly accurately because you have so much information from all that video you took, and you know so much about the movement of the car, right? Once you've got that, you can do this trick where if you've got a 3D representation of a fire hydrant in a scene, it's pretty easy for a giant supercomputer to look at that and say, that's a fire hydrant. And here are its exact boundaries, right? Because you're not doing this on a little workstation. This whole thing is the scene is getting built in a big computer, right? All the other cars can be super accurately labeled while they're in 3D, right? So now you've got a very accurate labeled 3D scene because you've cross-correlated all this video and you've made this super detailed model of the environment during that 10-second capture that you did. And the characteristics of that actually make it easier for it to be really accurately labeled. So once you've got all those labels, you can then go back to the video shots for each one of those. And every single one of those frames, you can exactly label because because the computer model tells you there's a fire hydrant in this location. It's exactly this shape. So back propagating those labels to the frames that originated from is trivial. It's really easy, right? So basically, from an operational standpoint, you got this big computer, you dump this video in, and then the video, it also has the inertial data for the car and whatnot, which you will use to correlate the ego perspective on all the cameras when they move. The computer can give you really good labels for all the objects in the scene. There might be thousands of objects, and I think I figured out there are 2,880 frames of video in 8 cameras by 10 seconds by 36 frames per second. So you get all 3,000 odd frames with maybe 1,000 different objects. You get them labeled, and a computer does it, and then maybe a human checks it. And a human would only check it in situations where the computer didn't have high confidence that it got it right. So this is really close to auto labeling. And the output of it is really high quality labels for all your video frames and really high quality labels for the videos themselves, because you can treat video objects as separate. And you have a ground truth 3D scene that you have produced also, which is like a 3D model of the scene. And that's also a trainable component, right? So for instance, if you have a neural network where you're training a neural network against this data, and the neural network it's trying to predict what happens in the future. Like you have a pedestrian in your scene, right? And the pedestrian has some kind of behavior, and say one of the neural networks you're trying to predict is like, will this pedestrian step off the curb and enter my path, right? You know a lot about exactly what that pedestrian did do and will do because it's all in that recording, right? So now you have a really good piece of data for training a neural network that tries to make predictions about what the car saw when it went through. And you've got 3D data, you've got video data, and you've got tons and tons of still frames. So you can push this data into the training of your network at lots of different levels to provide a good signal to the neural network when it's training to make it as accurate as possible. So, and this is 3,000 frames that you got for free, at least from a human labor standpoint, right? Because when they in Karpathy's talk, he talked about they had 1 million videos that they did this with, right? So 1 million scenes, 1 million times 8 videos. So imagine what it would take for human beings to label, all of those frames. Like it couldn't be done. Like you simply couldn't produce this training data set without auto labeling. And you can't get really good auto labeling without going the path that Tesla's doing, which is basically take the data, use it as constraints to predict the actual 3D scene that the car went through. And then once you've correlated all that stuff and you know all that information with great accuracy, you back propagate to get the labels for your images and your video. Am I explaining that?
Yeah. So, I mean, to summarize it, let me know if I'm, missing something, but you have this video clip, let's say it's 8 cameras, 10 seconds, whatever. It gets fed into this supercomputer, which basically takes this video and transforms it into a 3D scene where it basically, imagine like a bird's eye type of view where it shows all of the objects moving around at whatever distance and is able to label each object at a much higher confidence than, let's say, just an individual video frame, because it has all of the frames before it and after it, right, where it could identify the same
it has
object.
So many different things telling it this is a fire hydrant. It doesn't just have one, maybe partially occluded, maybe shaded, maybe not from a good angle video. It's got a bunch of photos of the fire hydrant from a bunch of different angles and maybe a bunch of different cameras, so it can be very confident that that's a fire hydrant when it sees it. I had these 2 frames. Maybe I could share this.
Yeah.
Oh, we're still sharing, so
yeah, go for it. Yeah.
Okay, so these are 2. This is actually, these are 2 slides from a little video clip that Andre showed, right? But these are like sort of 2 shots of this video scene rendering thing that I'm talking about. So in the image, you see in the bottom left, you see the image that they started with from the camera, right? This is just a single image from the front main camera. And you can see that they're training against producing this output data, right? So I've got kind of 2 different angles. In the video clip, it starts high and it kind of zooms in. So this is an actual 3D scene, this gray section on the left. And there's only a few objects in here. You can see there's a few cones that are scattered. There's the orange sign to the side of the car, and then there's the car ahead, right? But you can see that from the multiple angles they have there, they've created a 3D scene. Like they've got this high resolution 3D scene that they have constructed. And this is, Andre showed this in the context of auto labeling, that essentially you do all this stuff offline in that big computer to build your training set. And then this becomes training data that you train back against when you come out. So while I don't know that they're doing the exact process that I described, I know that process I described is possible, and it would certainly produce good results. And the only thing that I don't know is how much computation would it take. It takes a big computer to do this stuff and do it well on tons of video. But the images that Andre showed suggest that they're doing some amount of it.
Yeah.
Right? I mean, because he's showing 3D scenes they're constructing from these captures.
Yeah, definitely. I mean, so it seems like, so you have video to 3D scene, and then from the labels created in the 3D scene, then you basically propagate it back to the video frames themselves. So then you're labeling with each video frame all of the objects, all of the depth and velocity of all the objects. I'm wondering also, it seems like if you have that 3D scene over 10 seconds, you have this element of time where you can predict like certain things, right?
Right.
For example, the pedestrian, whether or not they're going to step into the street or not, or whatever. And how is that kind of labeled onto the scenes themselves? Is there some type of extra variable on like the likelihood of certain objects like performing different actions? And like, yeah, how does that predictability of like the future?
So if you want to build a neural network to make a prediction, you start with data which it can be trained against and tested against, which means it has to have the input that the neural network can use to make the prediction, and it has to know what the result of the prediction should be. You have to know the right answer so you can back propagate and train the neural network to produce the right answer. So in the case of the pedestrian example that I have, like, I don't know if Tesla is labeling pedestrian movements right now, but if you wanted to make a neural network that predicted pedestrian movements, you would need a training data set that had labeled pedestrian movements in the training set. So if Tesla has these clips, and if at some point in the future they decide they need labels for the pedestrians, they can always rerun the clips again, right? And add another filter to it that says label this pedestrian as, will step off the curb in the future, right? Mm-hmm. So that when a neural network looks at the pedestrian and looks at their body language and how they're moving and that kind of stuff, it can be tested as to whether it could accurately predict whether that pedestrian would step off the curb in the future. So they have to produce a training set so that they can train the network. And the training set has to have labels for all the things that you want the neural network to output. But your raw data doesn't necessarily have to be labeled in the beginning, right? You can go back to the data and relabel it or add labels to it later as you add functions.
Yeah. I mean, it seems like if Tesla is doing this whole process of video to 3D scene, then back propagating to the video frames with adding all the depth, velocity, and movements of all the objects, and then basically with the neural nets themselves, they're basically taking what all of these 3D scenes have, the advantages of all that extra information, but it almost feels like they now have the superpower where they could just take regular frames now, right? That real-time video frames like in the car, and they can have superpowers of predicting things that the frames themselves don't.
If it's possible to predict.
Yeah.
The network could learn to predict.
Yeah.
I mean, some things.
Well, I guess not even
possible.
Predicting, but just evaluating, for example, the depth or velocities or different, objects. Yeah. It seems like they're getting all of the benefit of the 3D scenes and what that gives, but in the actual just the regular video frames, right? They can process the regular video frames, but get all this extra information, and it seems like that's the key to hack or unlocking the whole, depth and velocity of every single, I guess, object in the. I mean, can they do it without doing that? Without the 3D scene, can they?
So there are probably other mathematically equivalent processes,
yeah.
And there may be processes that are more efficient than the one that I described. The important thing is that these 8 cameras are correlated. They're at fixed positions on a vehicle, and the vehicle is moving. We know approximately what the motion of the vehicle is, and we know that objects persist in the real world. I mean, we have all these things that we know. All of those things that we know, they're constraints on what the scene must be given what we saw in the cameras. So what this 3D scene construction language that I'm using to describe this is I'm essentially saying they've got these cameras. The camera inputs a reality. That's what was seen. What must the 3D scene be in order to produce what all these cameras saw? Because the cameras, they're constraints on what that thing can possibly be. And then if they're sufficiently good constraints and you have enough of them, you can be very confident that that's what actually was there in order to cause all the cameras to see what the cameras saw. And once you have that reality, the 3D reality that was out there, getting back to labels on all the individual frames or getting back to labels on the video becomes very easy, because the 3D scene would be incredibly information rich and incredibly high confidence, right? You're not, maybe that's a fire hydrant. No, that's a fire hydrant. I got 200 frames of that thing from like 6 different angles, right? I know it's a fire hydrant. I'm extremely confident. So you have very high confidence of a lot of detail. And once you have high confidence of a lot of detail, you can take that information back to the raw footage that was used to create it. So like each individual frame, when it gets a label, oh, this is a fire hydrant, when you go back to that thing, it's getting labeled as a fire hydrant, not just because the supercomputer looked at that frame and thought it was a fire hydrant, because that supercomputer correlated what the vehicle movement and all the other frames also agree it's a fire hydrant. So we're super confident that that's a fire hydrant, and here's exactly where it is. Now, there are other processes you could use to do this. And Karpathy has said a couple of times, like when he talked about not needing radar, he's trotted out this line a couple of times where he said 8 cameras times 36, or what is it? A megapixel times 8 cameras times 36 frames per second is a lot of constraints on the world. what he's talking about there is like that's so much constraint on the world that we can have high confidence in what the actual state of the world is, right? Is at the end of the day, once you're all of the auto labeling process I'm talking about, a lot of this stuff happens in a supercomputer, and its job is to produce training data. But the point of that training data is to train a neural network that runs in the car that can do that trick in real time as you're driving down the street. Like it can understand the 3D nature of the reality that's driving through with high confidence. It can say that's a fire hydrant or that's a pedestrian, and they're going to do this because it's been trained on really high confidence, really detailed data to do that. And if you get to that point where the neural network can do that trick, obviously you can drive the car. But the reason that that Karpathy is confident that you can get to that point, that you don't need LiDAR, that you don't need radar, is because 8 cameras at a megapixel at 36 frames per second is a tremendous amount of constraints. You're narrowing down the possibilities that the world could be to a very little box, and you can be very confident that the state of the world is in that box because you've got such overwhelming amount of data covering it.
Mm-hmm. Yeah, interesting. We covered actually some of like the mechanics in our previous videos several months ago, and like of kind of the whole auto labeling through 3D scenes, and that was one of the most impactful kind of like aha moments for me when I was like, oh my gosh, you could actually back propagate, right? Labeling through, let's say 3D formations of 3D scenes. And
so like, they've got the equivalent of millions of labelers.
Exactly.
Right? Because you could never do this with any army of labelers you could expect to get your hands on. The computer. Yeah.
Exactly. And it seems like it's just this crazy step change in in labeling, right? And what you can label, how fast you can label, accuracy in labeling, which impacts the neural net's performance tremendously.
Because the data is the thing.
Exactly.
Right? The really high quality training corpus. And another Karpathy line was like, if you have a large, clean, diverse data set and you trained it on a big enough network, like he quoted Ilya Sutskever and said, success is guaranteed. Right. So I think he's really confident because all of those knobs, the large, clean, diverse, and the neural network, they can just keep making those bigger. Right. Mm-hmm. Like they can turn that crank as high as they need to in order to guarantee success.
Yeah.
And then it's a matter of time. You just have to do the work.
Yeah. And then it seemed like, several months ago when we were talking about this, it seemed kind of like, this is probably what they're doing or what they're headed into, et cetera. But hearing Karpathy basically saying, we don't know the exact maybe 100% details, but it seems like, this whole auto labeling is a huge focus. And then basically he's saying, this is what we've been doing it. It's like, it just actually, I was extremely, bullish back then about just, the prospect of auto labeling, but from Karpathy's talk, it's just like, wow, this is really happening. Like Tesla is pushing forward, like with auto labeling. And it's like, it just seems like, I don't know. I was impressed by the talk because I'm like, it just seems like it's just this, talk that just gets passed by. Not many people really like understand like the significance of like what's really happening. But
it's totally understandable that a lay audience doesn't understand the implications, right? But a thing that's really surprising to me is there's not really much discussion of this stuff, even among experts, as far as I can tell. About and I don't know how much of it is like they don't believe it's actually happening, or they're skeptical about, or a lot of experts, they're just not concerned with the commercial realities of this stuff. Like they're doing research or they're specialized in some segment of it, and they're not really interested in the bigger picture, right? Exactly. But like it's a really remarkable set of things, which I think is occurring in the world today, and there doesn't seem to be much discussion about it.
I mean, it's like compared to, I don't know how Tesla labeled, let's say 2 years ago or 3 years ago, their data, but it would seem like most of it probably, was it probably mostly by hand? Like, you have labelers.
They probably started with fully manual labeling, and they probably had a group of and Karpathy said they did. They have a set of tool developers whose job is to write software to make the labelers more productive. And there's some low hanging fruit. And so you pretty quickly can double quadruple, multiply the labeler's capability or productivity by 10x. But eventually, you can only give them so many Photoshop tools to make coloring the dots in the image faster. And eventually, you want to get to more sophisticated things where, like, you have a neural network, like, they're training neural networks to put boxes around things in images, right? You take the neural network out of the car and you have it do a rough draft, and then the human adjusts it, right? So instead of drawing all the boxes from scratch, it looks at what the computer did. And as the computer gets better and better, there's less and less work for the human to do. So, like, that's a thing that you can do. But eventually you get to the end of that, because that's limited by how good your neural network is today. And the next level you go to is, well, let's correlate tons of images. Like, let's step outside of what the neural network has access to. And get a bigger computer, give it access to more data, and get it to do even more of the labeling. And the end of that process, ideally, is you make each one of your labelers 1,000,000 times as productive as they would have been if they had to do it manually.
Yeah, I mean, correct me if I'm wrong, but it seems like what Karpathy is insinuating is, like, with this past 4 months of development, 7 rounds of shadow mode, etc., that with the 1,000,000 video clips, it seems like predominantly it was auto labeled. I mean, you did probably have humans, right, going through the labels where maybe the supercomputer had some low level of confidence, right?
They were working on the auto labeling, we know, more than 18 months ago. So it's likely that they came into this effort, this 4-month effort to get radar out, with auto labeling already being fairly mature.
Yeah. And so, I mean, it seems pretty fascinating that it seems like predominantly, like, the labeling is happening, but
like 99.999% of it will
right?
be automatic at this point.
Yeah, and it's just mostly the labels that the supercomputer is basically saying that they have low level of confidence the humans might review to make sure, right? So that's the role of the humans in labeling. It just seems like...
Yeah, I mean, you can just look at the number, 6 billion object labels.
Yeah.
Like,
yeah. How can humans do that?
Okay, well, they obviously didn't do that with 500 people. Right?
Exactly.
I mean, 500 people is probably how many people they've got, right? On that scale. I mean, they don't have 10,000 labelers.
Yeah.
Right. So 6 billion labels is a lot of labels in 4 months.
Yeah,
right?
Exactly.
And accurate, really good quality labels that have been cross-checked too. Like, that's a necessary input into this whole thing. They're not just like one guy's opinion at 4 a.m. Right?
Yeah. I mean, there's a lot of people who are claiming, like, Tesla will never solve full self-driving. It's a pipe dream. Like, 20 years from now, it still won't be here. But I don't know if they're really catching what's going on here. It's like, when I look at the real improvements in terms of labeling and the amount of data and just everything, it just seems like
mostly people just aren't paying attention to it.
It just seems like if you feed that into the neural nets, you're going to get, like, a crazy amount of improvement. And it just, I don't know, it just seems like,
It's how can it be that the world isn't like amazed and, isn't really paying a lot of attention to this? They're not.
It's crazy.
But then, I love this metaphor of the Wright brothers. I think I've probably tried this thing out. The Wright brothers were flying airplanes around it was years before people actually believed that it was I mean, people would see photographs in newspapers, like, of them flying airplanes, and it was just like, oh, that's fake. That's not real.
Yeah.
Like, people can't fly. They didn't believe that. And, like, there were high-ranking military officers in the United States that were writing op-eds in major newspapers, basically saying that flight was a pipe dream after the Wright brothers had already done it, right? I mean, you would think these people would be informed. It's very important to their thing, and yet they just didn't believe that it was happening. I think people's preconceived notions about the utility or feasibility, or desirability of things are so deeply embedded that it takes an incredible amount of there was this whole barnstorming era in the United States, like back in the 20s, when, guys would get in their biplane and they would fly around the country and they would make, $5 a pop taking farmers up for rides in the airplane. A barnstormer would, like, roll into town with his airplane. into a town where people believed that flight was impossible. Right? Like they'd seen pictures in the newspaper, but that stuff was all just made up or whatever. But and I mean that was it. That's what it kind of took to convince people it was real. You had to put them in the back of the airplane and fly them around. And the Tesla experience is kind of like that too. There's that whole thing about how you put people in the car and it makes convergence. Or like Sandy Munro, wasn't very impressed with autopilot until like he got in. I guess he got in Omar's FSD car, right, and rode around. And he's like, "Wow, this is amazing!" It's like, the videos have been out there for YouTube. You've been hearing about it for years. Why didn't you know, right?
Exactly. Yeah, crazy, man. This auto labeling. So, one of Karpathy's slide, I think you had it up there that said that they're applying auto. Is it something like they are applying auto labeling to all other FSD tasks? I don't know if you could get that slide up.
Yeah, you'll use it for all. Okay, so when he uses the term task, so that's a terminology they use internally inside the autopilot team. So the output of the neural networks is consumed by various modules that do various parts of the driving decision, and they call those tasks. So like the outputs from the neural network that go into, say predicting the future path, like that might be a particular task that's going on. So the AEB is a task, right? Like, should I slam on the brakes right now because an emergency is occurring? Like that could be,
got it.
I mean, I haven't actually seen that task because I haven't seen the neural networks yet that this stuff is going into, but they probably have an AEB like task and in the system right now. And now they've basically they've prioritized using the auto labeling stuff for getting that task working. So my interpretation of him saying we want to use it for the other tasks is, this thing we've used it for this part of the neural network, and we're going to use it for all the others too.
Mm-hmm. Got it. Fascinating stuff. What I want to do is I want to wrap up this episode. In the next episode, I want to talk about the supercomputer that Tesla has been developing. Karpathy kind of showed a picture of it, gave some specs. I want to hear James's perspective on exactly what this beast is and what Tesla has plans in the future, right, for supercomputing Project Dojo. Maybe I'll also ask about Tesla AI Day if James has any ideas on what to expect there. So we'll see you guys in the next episode.